This lesson is on the reaction mechanism and how to identify the rate determining step and how to verify if a set of elementary steps are valid for a given chemical reaction. So we learned in the last lesson that the rate determining step is your slowest step in your reaction. So for this reaction where you have two hydrogens reacting with two nitrogen monoxides forming your products, you're being given the reaction here and you're being told the experimental rate law. So this is the experimental rate law that would have been determined by using a method of initial rates. It's your differential rate law. So this is given to you. And what we want to answer is we want to determine which step in the reaction mechanism would be the rate determining step. Remember, the rate determining step is your slowest step in your reaction, and we abbreviate rate determining step as RDS. So you're given two elementary steps, and you're asked to determine which is the which is the rate determining step. We learned that with your elementary steps, you could write your rate law from their molecularity. Well, in step one, we have two NOs here and one H2 here. So this is a termolecular elementary step. So if we wanted to write the rate law for step one, we would write it as rate equals K. And since this is termolecular, you take concentration of your hydrogen, H2, and that would be raised to the first power, times concentration of your NO, and that will be raised to the second power because of the 2 here. Now remember, you can only write rate laws from elementary steps directly from their molecularity. This would not work for the overall reaction that you were given up here. So this is the rate law for the step 1 elementary step. And if you compare this rate law to the experimentally determined rate law, notice that it matches. Rate equals K times NO squared times hydrogen to the first. Well, that's exactly what we have here. So that means that step 1 is your rate determining step for this reaction. If you were to write the rate law for step 2 from its molecularity, it is bimolecular. So you would write rate equals K times N2O to the first power times concentration of hydrogen to the first power. This does not match the rate law that was determined experimentally, so that's why we know this is not the RDS. Step 1 agrees with the experimental rate law, therefore we would say step 1 is your rate determining step. Now, another thing you need to be able to do, looking at your elementary step, is identify any intermediates. So for the same reaction as we mentioned before, it may ask you which species in the mechanism would be intermediates. So what an intermediate is, it's any species that does not show up in the final balanced equation. So let's take a look at step 1 and step 2, and let's look and see what cancels out. So if you look across at this, you notice that in the first step, water is formed as a vapor, and water is formed in the second step as well. So since they're on the same side, they do not cancel. Look at your NO2 gas. The NO2 is produced in step 1, but if you notice here, it's consumed in step 2. These would cancel out. So NO2 is your intermediate. It is produced in one step and it is consumed in the very next step. You could have more than one intermediate in a mechanism. So what you would do next is you would write down the remaining substances that did not cancel. So notice there's 2 hydrogens here, so that's why we see 2 H2s plus 2 nitrogen monoxides, pull it down, and then there's 2 waters formed and 1 nitrogen gas. But you would identify the N2O as your intermediate in the mechanism. All right, so let's look at another example. Here you're given the chemical equation. This is the overall chemical equation. And at the moment, it is not balanced. So let's let's check and see. 1 nitrogen, 2, 3 oxygens, 2, 3 oxygens. Okay, it is balanced. So 1, 1, 1, 1 balances the equation. So it says for the reaction above, if the experimentally determined rate law is rate equals K times NO2 squared. So this would have been determined using method of initial rates. So what they're giving you, they want to know if the mechanism proposed here is acceptable. And then it also wants you to determine what the intermediates are, if there are any. So to determine if the mechanism is acceptable, we learned in the last lesson that the mechanism must agree with the overall balanced chemical equation, which means we need to try to add these two together and see if they give us the overall equation we see up here. And then the other thing you're looking for is to see if the rate determining steps rate law matches the experimentally determined rate law. So let's write the rate law for the rate determining step. Notice in this one, they're telling us the rate determining step. This is a bimolecular reaction, so you would write rate is equal to K times NO2. And since this is NO2, both of these are NO2, it will be NO2 squared. So when you look at this and compare it to the experimentally determined rate law, they do match. So that means that the first criteria is met. The rate determining steps rate law must match the experimental rate law. The second criteria is when you check to see if these two elementary steps add together to give you this overall reaction that we see up here. So that's the next step to see if it's in agreement with it. So let's cancel out any intermediates. Notice that the NO3 here is a product and here it's a reactant, so it cancels out. Also notice that we have an NO2 as a reactant here, and it cancels with the NO2 that's a product here. Those are the only species that cancel. So you actually have two intermediates here. The intermediates are the NO3 and the NO2. They're your two intermediates. Pull down what did not cancel. So you would write down NO2 gas plus carbon monoxide gas yields NO gas plus carbon dioxide gas. So what you want to do is check and see if this agrees with the given reaction. So NO2, carbon monoxide checks, nitrogen monoxide checks, and the carbon dioxide checks. So the second criteria matches. So you would say that yes, this is a probable mechanism. Let me go back and write that in. This is an acceptable mechanism. And again, your intermediates were the NO3 and the NO2. Let's look at another example. Here we have nitrogen dioxide plus fluorine gas forming two NO2Fs. So we have two fluorines here, two nitrogens, and 4 oxygens. So it looks like this is not balanced. Let's put a 2 here. That gives you 2 Ns, 4 oxygens, 2 fluorines, and 2 fluorines. So 2, 1, 2. There's your balanced equation. So it says for the reaction above, is the experimentally determined or is this a proposed mechanism an acceptable mechanism? And then what are your intermediates? Now, why don't you pause the video and see if you can work this one through and then resume the video and see if you agree with what I get. I'm going to go ahead and continue. So we're going to first write the rate determining steps rate law from its molecularity. So you would say rate is equal to K times NO2 to the first times F2 to the first. Okay, and so you're going to check and see if that matches, and you'll see that they do. So that checks, match. And now you want to add these together and see if your intermediates, when they cancel, give you this overall equation that we have up here. Okay, so we're going to cancel the intermediates. An intermediate is fluorine, and I think that's it. So now let's add these together. They're on the same